Hello guys, Assalamualaikum warahmatullahi wabarakatuh and a very good morning. So the other video I'm already talking about 3 electrode system in supercapacitor. So in this video, I'm going to talk about 2 electrode system in supercapacitor. So basically, in potential stat, you can have working electrode, you can have counter electrode and also reference electrode. This is 3 main electrode. So what you did into electrode system, so just leave the working electrode and reference in the bottom and counter at the back. So you connect together and become 2 electrode system. For your device in supercapacitor, you should have the positive electrode and also negative electrode sandwiched together. So in the presence of separator, which you already soak in the electrolyte. If you are using the gel electrolyte, no need to have a separator. But sometimes they use separator even though they are using gel electrolyte. Okay, enough with that. So the setup is simple. You have you have your positive electrode and negative electrode sandwiched together. If you study about asymmetric supercapacitor, if you study about symmetric supercapacitor, just use the same electrode and sandwich together. So you can call that symmetrical supercapacitor. If you have positive and also negative, you call that asymmetric supercapacitor. So this is also applicable for other application. For example, you have supercapacitor, where your positive electrode normally battery type electrode and your negative electrode normally carbon-based electrode. Also you sandwich together. So back on our main question about 2 electrode system. So this is the setup. So in 2 electrode system, again you also need to repeat the same measurement that you did in 3 electrode system. It's the same. You must run the cyclic photometry from the potential window. So now the first thing first, we are talking about the potential window. If you are using in, for example, different, you have working, you have positive electrode and also you have negative electrode. So you have 2 set of potential windows. So what you're going to do, for example, your positive electrode, the potential window from 0 to positive 1, negative electrode from 0 to negative 0.5. So in device, when you sandwich together, you should combine the potential window. For example, positive from 0 to 1, negative from 0 to negative 1, combine together, the negative become positive. So now you have extra 0.5. So now you need to scan from 0 to 1.5 because you already assemble, you already device, making a device. So you should consider the potential window of both electrodes. Okay, back to number 2. After you know about the potential window, wait a minute. So some people might ask, if I have symmetrical, so let's say I just study about positive electrode from 0 to 1. So what is my next potential window when I did a device? So just increase, so 0 to 1, so it is symmetrical. So you must run from 0 to positive 2. So normally, the bigger the potential window, you must test for the capability of your device, whether it can achieve that potential window or not. If not, you must justify why it happened. Okay, next. Okay, the first step, you know the potential window. So you already know the potential window. Next, you must run a characterization, CV also, to justify whether your material, your device capable to achieve or maintain the shape of CV at high potential window. So for example, 0 to 1.5, you must run from 0, 0.5, 0.75, 1, 1.25, 1.5, whether your device can achieve that the potential window. Okay, next, number 2. After that, you must run the GCD. Okay, the GCD for device, same setup. So the only difference is about the current density. You can set the current density, but what you need to think is about the current density is make sure that, for example, you run at 1 ampere per gram, make sure that your device capable to achieve that potential window. If the triangle not achieve, for example 1.5, so means that you need to increase the current density. So make sure that CV and GCD must in agreement with each other. Okay, next you can run EIS and then stability test. Okay, normally in supercapacitor they do stability at least nowadays 5,000 cycle, and they like very preferably if you do 10,000 cycle. So the bigger the number of cycle, the longer the stability is. When your sample can stable at high cycling stability, more journal or more author would appreciate to have your paper in their publish. They can publish your paper. So I think that's all. If you are running a supercapacitor for 2 electrode system, so you should bear in mind about certain point that I talking to you. So you must know about the potential window, so the shape of CV, is it can achieve that potential window or not. And also if you get the stability around 75 and above, it's quite good. And if it's dropped, it's okay, you can explain whether your material why it cannot retain high cycling stability. I think that's all for 2 electrode system. It's a short but maybe a little bit lacking. You can comment and you can give your opinion and so on. I think that's all. Bye. See you.